Well, hello again. I was very disappointed to find out this morning that the Arecibo radio telescope in Puerto Rico is going to be scrapped. Now, apparently it got damaged. There's a big hole in the dish there by one of the support cables, which fell down and created a great big hole in the dish. And the Arecibo radio telescope has been used for a very long time for a lot of interesting stuff. It's been used to map the surface of Venus with the planetary radar, believe it or not. The transmissions from there are so powerful they can bounce signals off the surface of Venus and create a picture with it. And we'll have a look at one of those in a little bit. And also, of course, it was used I think back in 1974. To transmit a very high power signal out across the galaxy that showed any aliens that might receive it. Any aliens that might have their own SETI type project going would be able to receive it, and it showed where we are, you know, the sort of dish size that we used, and a few other useful things that would be handy to any invading alien force. So let's just have a look at. Let's get a better picture of the overall installation. There we go. So there it is. It's not actually a parabolic dish. This one, it's a hemispherical dish, and it's built into a natural depression into the ground. Get that a bit lighter, can we? So you can see that a bit better. Now, this. I think if I remember right, I'll read the thing in a minute, but I think this is about 1,000 feet across, this dish antenna, and this main structure here, which contains the 1 megawatt microwave transmitter that they used to send messages out into space, and for the planetary radar mapping, is supported by these steel cables here. So this is 900 tons, this thing here, and it's held up by got these 3 big towers, and they can move this around, and the way they sort of steer the dish, if you like, so that it's looking at different parts of the sky, is by this moves along an arc that's suspended below that, and it also rotates, so that they can move this point around here, and what that does is it changes the angle that the dish is looking at the sky effectively. And they got a contracting company in to have a look at it, and they said that it was too dangerous to repair and suggested that it be demolished. So they're going to demolish it after decades of research, including some SETI research. It's going to be demolished. I think that's a great shame. You can have another look here at the a bit of a closer look at the damage. I thought I had a better picture of the damage, but apparently not. Oh, that's sort of from ground level, and it showed that it's this hole here. Yeah. When seen from the underneath, because bear in mind that's 1,000 feet across that dish, that is a massive hole, and it showed all the panels hanging down underneath it. It doesn't look in terribly good condition, you know, considering the frequencies that they're working with. I would have thought that it would have been advantageous to have that as smooth as possible, and to get rid of any of this sort of moss. You know, all this sort of stuff might sort of scatter, certainly millimetric, but maybe centimetric signals that it's receiving as well. So that might not actually be, that might sort of slightly unoptimize it, if you know what I mean. Oh, it's really disappointing. I've lost that other bloody picture. But hang on, let's just read. I think this is the one where we've got some information here. Yeah, the US National Science Foundation says it will close down the massive space telescope at Puerto Rico's Arecibo Observatory, ending 57 years of astronomical discoveries. I'll leave a link to this article below so you can read it for yourself. After suffering 2 destructive mishaps in recent months. I didn't know there was 2 either. I suppose the conspiracy theorists are going to say, well, this is the only planetary radar, the only long-range radar capable of detecting an approaching alien spacecraft or alien fleet, so it had to be destroyed. Yeah. There's just no hope for some people, is there? Operations at the observatory, one of the largest in the world, were halted in August when one of its support cables slipped loose from its socket, falling and gashing a 30-metre hole. So that hole is 30 metres in the telescope's 305-metre wide reflector dish. Another cable then broke this month, tearing a new hole in the dish and damaging nearby cables as the engineers scrambled to devise a plan to preserve the crippled structure. Well, this is what happens when you leave it. So the cable broke and they're all standing around scratching their rear ends. And because you've got one cable support missing, bearing in mind that centre structure is 900 tonnes, you've got a lot more stress on the other cables, so another one's failed. And I think they're right. The way it's going, it's all going to collapse in a big heap before too long. But that's because they didn't get onto it in the first place. If they'd have just immediately got onto this job and got that cable replaced, they could have saved it. NSF has concluded that this recent damage, so this is this secondary damage to the 305-metre telescope, cannot be addressed without risking the lives and safety of work crews and staff, said Sean Jones, Assistant Director of the Mathematical and Physical Sciences Directorate at the National Science Foundation. Yeah, so that's a real shame, that. Supportive cable slipped from its socket in August, falling and gashing a large hole in the dish. Another cable then broke in early November, causing more damage, and that's because they didn't fix the first cable. And the other cables were all stressed, had a lot more stress put on them. It's been there for 57 years, remember. The telescope helped detect asteroid Bennu, laying the groundwork for NASA to collect samples from it with a robotic probe. It's also used for tracking near-Earth objects, tracking asteroids that could potentially hit the Earth, that sort of stuff. So yeah, it's really hard to imagine why they wouldn't find the money to fix this. Let's have another look at some of the stuff. I mean, the Arecibo transmitter is so powerful, 20 terawatts. That's 20 trillion watts. That it could map the surface of Venus. Okay, not with a great resolution, but you're still talking about firing radar pulses from Earth, bouncing them off the surface of Venus, and then getting them back to the Earth with enough clarity to be able to map the surface, so you can see mountains and valleys and all that sort of stuff. And this little rectangle here is shown here in a much higher resolution. This is the same strip. So this strip here, this strip here is this strip here, and that's from the Magellan probe that actually went to Venus and looked at it from orbit. So big difference, but I mean, that's still amazing that you can do that. You know, you can sit on the Earth with a planetary radar and map a nearby planet and show mountains and valleys and that sort of stuff. And curiously enough as well, that it's a very high power radar. You can map a planet's surface with it, can find asteroids, it can map asteroids and all this sort of stuff. And it's never ever seen an alien spacecraft. I think that's quite interesting. Now this is the Arecibo message. You may well have heard of this. Back in 1974, the most powerful broadcast ever deliberately beamed into space was made from Puerto Rico. The broadcast formed part of the ceremonies held to mark a major upgrade of the Arecibo radio telescope. The transmission consisted of a simple pictorial message aimed at our putative cosmic companions in the globular star cluster M13. This cluster is roughly 21,000 light years from us, near the edge of the Milky Way galaxy, and contains approximately 1/3 of a million stars. I think the thinking has changed these days. I don't think, if they were going to do something like that these days, I don't think that's what they would do. I think probably the easiest thing to do, if you really want to attract any aliens out there, the attention of any aliens out there that might be running SETI projects of their own, is to just beam a really high-powered message at the centre of the galaxy. Because that will be going straight through the galactic plane, and you're going to come across far more stars by doing that than sort of beaming it out at the edge. So I don't quite know what they were thinking about there, but and of course M13 star cluster isn't going to be in the beam by the time the beam gets there in 21,000 years, or 20,900 and just deduct the amount of years. So what would that be? That would be 46 years. Deduct 46 years off of 21,000 years, and that's how long it's going to take to get there. The broadcast was particularly powerful because it used Arecibo's megawatt transmitter attached to its 305 metre antenna. The latter concentrates the transmitter energy by beaming it at a very small patch of the sky. The emission was equivalent to a 20 trillion watt omnidirectional broadcast. So what that means is the effective radiated power was 20 trillion watts. So if you can imagine an omnidirectional broadcast of 20 trillion watts, and you cut a small slice out of that, and you made it the same shape as this beam that they sent out into space, that's that effective radiated power by using that 1 million watts that would have been radiated omnidirectionally and squeezing it down into a beam. If you can imagine a balloon full of water, a round balloon full of water, and then you squeeze it into a sausage, it's going to push out quite a long way, isn't it? And that's what that means. So there's no free energy there. That's effective radiated power. So if you wanted to get that same signal strength at that same distance from an omnidirectionally broadcast signal, you would need 20 trillion watts, is what that means. But by squeezing a 1 million watts into a fairly tight beam, you can achieve the same signal strength over that same distance. The message consists of 1,679 bits arranged into 73 lines of 23 characters per line. These are both prime numbers and may help the aliens decode the message. The ones and zeros were transmitted by frequency shifting at the rate of 10 bits per second. A little bit of technical info about the signal. Pretty crude stuff, but we're talking about 40 odd years ago. And there's the pictorial representation, the digital pictorial representation of the message that was sent. And this is the Arecibo telescope. This is showing that we come from the third planet from the star, different sizes of the planets, how many planets are in the system, how big a person is, some of this other stuff. I'm not really sure what this is. But yeah, so some interesting stuff has been done from Arecibo. And it's one of the few installations around the planet that's doing serious SETI stuff as well. So it's a real shame that that thing is closing down. Now, I was this just made me think of, I can't show you an image of it without, I'd have to pause it and then do something else, but so I won't do it at the moment. But the plaque on the side of the Voyagers shows a similar sort of thing to this. It shows the third planet, and it shows the size of the Voyager craft against the size of a person. And it also shows the coordinates of planet Earth from different pulsars. Now, pulsars have a unique pulse repetition rate. if you know anything about radio astronomy. So the Galaxy already has a GPS system. It's easy to navigate around the Galaxy because there are pulsars, these pulsating stars. They have a very, very accurate pulse repetition rate, and they're all unique. And you know where these pulsars are, and you know so if you've got any kind of timing pulses from different directions, you can figure out where you are in 3 dimensions very easily. So and I thought that was probably a pretty bad idea by showing where the planet Earth is precisely, using bearings to pulsars and showing the pulse repetition rate of the pulsars, so there's no ambiguity with regard which pulsars they were talking about, pinpoints us very precisely in space, and I thought that was probably not a terribly good idea. But anyway, that's the Arecibo Radio Observatory and planetary radar and near-Earth object radar, and they're closing it down. So they're gonna pull it all down. So that will be the end of an era. It really will be. The new SKA that's being built in Australia, in the SKA Pathfinder, does not have transmit capability. It's a receive-only system for radio observations of the galaxy and galaxies. So we're losing a significant piece of equipment there. Great shame. Is there anything else? I don't think so. Just a quick video to let you all know if you're unaware of this. I'm sure that people that watch my channel would have an interest in this kind of thing. And contrary to what you may hear from the conspiracy theorists, SETI is the only realistic way of we're going to have of proving alien life exists. Beyond aliens actually coming here and landing on the White House lawn, or landing in a local recreation area, and have every television channel and every person with an iPhone live streaming their arrival. As always, thanks for watching, and maybe I'll catch you again.